Welcome to Delta Learning Labs. Today we are going to learn about energy stored in chemical bonds. Have you ever felt heat coming off a fire? That heat is energy coming from the chemical reaction of the burning wood. In a burning fire, wood and oxygen react to form carbon dioxide and water. The simplified chemical formula for burning wood is CH4 plus O2 reacts to form CO2 plus H2O. In the chemical reaction, the CH4 bonds and the O2 bonds break into their base components and reform into CO2 and H2O. Breaking a chemical bond requires energy. This energy is taken from the surrounding area. However, forming a chemical bond releases energy into the surrounding area. In any chemical reaction, chemicals are broken down and new ones are formed. Thus, in any chemical reaction, energy is taken in from the surroundings and energy is released into the surroundings. If more energy is required to break the original chemical bonds than to form the new chemical bonds, the area surrounding the chemical reaction will have less energy than it started with, and thus it will be cold. This is called an endothermic reaction. If the reaction releases more energy into the surroundings than it absorbs, the surrounding area will have more energy than it started with and will be hot. This is called an exothermic reaction. A fire is an exothermic reaction. However, there is plenty of wood sitting in the air, but it does not all burst into flames. Why? To start a fire, you use a match. What does a match do? All chemical reactions require activation energy. Activation energy is the needed energy added to the reaction to start it reacting. In the case of burning wood, the match adds the needed activation energy. Stirring can add enough kinematic energy to start chemical reactions. This graph shows an exothermic reaction with its activation energy. The chemicals have less energy at the end than at the beginning. The rest of the energy goes into the surroundings. The bump in the middle is the activation energy. This graph shows an endothermic reaction. The chemicals have more energy at the end than at the beginning. Thus, it needs energy from the surroundings to form. Now let's go into the lab and do an experiment. In today's experiment, we will perform an endothermic reaction. On the table are all the chemicals and supplies you need. Within the beaker is a wireless thermometer that projects the current temperature onto the blue screen on the table. I will first demonstrate the experiment, then you can do it. In today's experiment, we're going to place this glass beaker on this wooden block. This wooden block has been fully soaked with water. We're going to add ammonium chloride and barium hydroxide. The first step is to inspect our lab equipment to make sure there are no errors. Investigating the lab equipment ensures a safe lab experience. Place the glass beaker in the middle of the wooden block. Dropping it gently is best. Take the lids off the chemicals. And pour in as much as you like. With the more chemicals that are in there, the bigger the reaction you'll get. And now stir it, which adds the needed activation energy. I'll let you see what happens. Now it's your turn. Well done. You froze the block of wood to the beaker. As you may have noticed, all the doors in this building are locked. The locking mechanism is controlled by the red cable in the corner of the room. Can you use what you learned today to escape